Hey everyone, and welcome to the March edition of WestWatch. I am Joe Casola. I'm actually not the NOAA Regional Collaboration Lead, even though I'm stealing their GoToMeeting for this. My job at NOAA is the Western Region Climate Services Director, so I help folks kind of connect with climate information and also connect the dots within NOAA about all the great climate resources we have. For this month, first, let me introduce WestWatch. In case you haven't been here before, WestWatch is a monthly webinar series that brings together NOAA staff and our partners from across the region to share information about climate observations and impacts across the West. We have two different formats. We do a panel on specific topics, which is what this month is, as well as just general climate overviews. And if you ever miss a session, this website, the NOAA.gov WestWatch, has our old videos, and I am very close to getting January and February posted, so I apologize for being tardy with those. Today, we are really honored to have with us Michelle Leroux. She is with NOAA's Climate Prediction Center and kind of my go-to expert on all things ENSO, and I think she's got a really cool presentation. She's going to look back at the ENSO that we're kind of, let's say, decaying, I think might be the right term right now, but look at some of the forecasts that we had from earlier in the fall, as well as and to compare it historically with past ENSO events, as well as to talk a little bit about impacts. A bit of housekeeping before I turn things over to Michelle. I do have one quick poll question I'd like to share, which is the same poll that we have for folks every month. Have you attended WestWatch previously? Give folks a few minutes to click their answers. Hopefully this is showing. Oops, didn't show. There we go, that's what I want to do. Yes, so most folks have attended previously, so great to see you all again. And we've got a few diehards here and a few first timers, so welcome, and we hope that you'll enjoy and come again. So let's see now. Stop the poll. To slideshow. Great. We'll have Q&A during the session, so please feel free to drop your questions into the questions box. Like I said, these sessions will be recorded, so you can come back and watch them later. We really appreciate it if you can fill out the post-webinar survey as well. Just to set context, I wanted to give a quick overview of the temperature and precipitation that we've experienced in the West in the water year and in December, January, February in winter, just so it provides a little background for, I think, what Michelle will show. These are two maps of the temperature anomalies. The left one is the water year from October through February. The right one is just December, January, February, and you can see mostly warm anomalies everywhere. And the pattern is not all that different for the winter relative to the water year. It's also been wetter than normal in most of the West. And these two maps, again, on the left showing the water year, on the right showing December, January, February. You've got more greens than browns, with some exception in kind of the northern Rockies in Idaho and in western Montana. You see a little bit of a flip in the Northwest, that things in kind of Western Washington have been dry-ish, but the last couple months slightly better than things were when the water year started. But most of the West above average or above normal rainfall. This is what the drought monitor shows, which is kind of a nice integration, but a maze of hydrologic conditions. You can see very, very few areas showing anything more than about abnormally dry, again, with the exception of the northern Rockies, and the Southwest in Arizona and parts of New Mexico. And if we compare this to where the water year started, you can see we've had pretty substantial improvements in places that did have drought. And here's kind of the change map where you see a lot of greens, even in the Northwest, where or not even in the Northwest, but in the North, again, indicating that kind of flip. We had a dry start to the water year, and then things improved in the last few months. And just kind of a longer term context, these are 3 snippets of the drought monitor from the last 3 Marches. So March 2022 up in the upper left, when there was drought almost everywhere. Last March, where you see substantial improvement, and then even fewer areas of drought in the current March. So just to reinforce the fact that we've had kind of a wet water year so far, and this is kind of 2 in a row for a lot of parts of the West. Our snow story does diverge from the precip story, mostly in the northern tier of the West. You can see that you have more of the hot colors up there, where we are below kind of our normal snow water equivalent. A lot of the Sierras and the Rockies, Great Basin doing quite well, but the Northwest, largely due to being so warm, has this kind of separation where you've had decent precipitation, but not as much of not in the right form, not as much in snow. Now I'd like to just turn things over to Michelle to talk a little bit more about these impacts, but really about what we've experienced here with respect to ENSO and kind of the evolution of ENSO and how our forecasts have done. So I'm going to switch sharing over to Michelle.
Okay. All right. Thanks so much. Appreciate being on here. I was putting together this presentation, and what I often do is I go back and look at my previous presentations for various webinars. And so, funny enough, it's almost to the day that I presented in 2023. So 1 year later, let's look back at what happened. Perfect timing. So first, I want to acknowledge my team there. This forecast process would be a complete catastrophe if it weren't for the people who are listed there. And this is the team that meets once a month and goes over the ENSO status and also the forecasts. And really, they're the reason that I'm going to show you some pretty decent forecasts here. So we obviously had a pretty significant El Nino, at least from the standpoint of sea surface temperature anomalies. I'm showing you a video here from October 30th through January 7th. And at that time, we were basically nearing the peak in the tropics. And what was interesting here was, of course, we had the conventional warming in the east central eastern Pacific, but we also had a lot of warming to the west as well. This isn't as common with El Nino. El Ninos tend to be cooler in the equatorial western Pacific, and we didn't really see much of that this year. But we did have the strong event, and it was not just in the ocean. We also monitor a bunch of atmospheric metrics. And here I'm showing at the bottom one of those. This is called outgoing long wave radiation, and it's just an indication of cloudiness, or at least in the tropics, rainfall. And we had a pretty conventional signal of enhanced rainfall near the date line. It did extend into the eastern Pacific, but it stayed north of the equator. And then over Indonesia and the maritime continent, we had less rainfall. So this is pretty much a dead-on signal in the atmosphere with respect to El Nino. And you can look at other measures like the equatorial SOI to see that we were fairly significant from that standpoint as well. Okay, so conventionally what we do is we take this region of sea surface temperature anomalies. They're anomalies, which means we're subtracting the seasonal cycle out. And we call this the Niño 3.4 index, or the Oceanic Niño index, or or as I say, ONI. And the ONI is just taking the monthly values or weekly values and daily values in NINA 3.4 and then averaging it over the course of a season. And for us in the Weather Service, the season is any 3-month period. So November, December, January is the season. December, January, February is the next overlapping season. January, February, March is the following overlapping season. And so this is how we identify ENSO, El Nino and La Nina, because it is a seasonal to interannual climate phenomenon. It's not, while you can, in principle, see signals of El Nino in subseasonal data, it's just not as strong. So when we identify, and so we're using these 3-month overlapping seasons, our primary data set is in sea surface temperatures, and we just kind of roll through the sea surface temperature anomalies, and we get this time series. This is using ERSST from our colleagues at NCEI. And red areas are the historical El Niños, and blue areas are historical La Niñas. And you can see our most recent El Nino here, just barely. It didn't quite get there. You have to round up to get there, but just barely. It was like 1.95. So, if you think 2 is the next category of strong event, then and you round up, you got there. But that's a little bit of just horse trading. So anyway, it was a significant event, not quite as strong as what we've seen with like 2015-16 and 97-98, but it was definitely up there. And we can see that by looking at the evolution of the ONI for each of these years going back 1950. So each of these lines is a different El Nino event. And then I color coded it by the strength of the event. And we use this 1/2 degree threshold cutoff. Very arbitrary, but it's a way to divvy up the intensities of El Nino. And so this is showing the evolution from early, really the previous winter to the most recent winter that we just had. So this is a very final point that we've recently calculated. Um, of the current event, which is this black line, and you see it's very clustered with these stronger El Nino events. And depending on how you rank it, if you look at November, December, January, it's ranked basically 5th, which is, and that puts it about the 20th percentile of all El Ninos, at least from this one measure. And obviously, if you use other measures of ENSO, you might get different rankings, but this is NOAA's official definition, and so is the one that a lot of folks focus on. Okay, so that's what happened. How did we do in terms of predicting this event? And I want to emphasize there's the team, right? So there's 10 members presently on the team, and we all sit down, we write down numbers. This is a consensus-driven process. That means everyone gets equal vote. And that is how we come up with our forecast. We are not independent from the North American Multi-Model Ensemble. This is a set of different models based largely in North America that we consider. And one of the reasons it's so valuable to us is that it's state-of-the-art models from different agencies, but almost more importantly, it's initialized right as we're making our forecast. And so this is usually pretty recent information that we're taking into account. And so it's fair to compare our forecast against the NME. We do this routinely, and it's just good to see. And now, but keep in mind that our forecast is not independent of the NME. We're using this information. So there's 3 rules for making real-time predictions. I think it's important to emphasize these because I think what we do is fairly unique, and I think others may make predictions, but they're not necessarily following all the rules. So the first rule is that you make routine forecasts. So we make a prediction every month, even on months where we do not want to make a prediction, we make a prediction, all right? So keep that in mind. And I'm already seeing media out there who are talking about this super El Nino and whether we hit it or not. And literally, I just read an article the other day that said NOAA said super El Nino. No, we did not. We never used those words. We never predicted a super El Nino. That did not come from us. And that particular source was not making a prediction every month, and they are not doing number two, number three, which is you need to self-reflect and go back and grade your predictions every month. That's how you become a trusted agent for forecasting. The other thing is, and a lot of people do this because ENSO is so sprawling and there's different ways to measure it. They'll sometimes, say, well, I'm trying to predict SOI and I'm trying to predict rainfall, and that's fine, but you still have to predict something, and you have to zoom in on that. You can't after the fact say, well, no, I decided to predict something else. So up front, we predict the ONI, we predict seasonal overlapping Niño 3.4 values. All right, so how did we do? So the top panel here is showing the NME model predictions for this event. I think the initialization starts in like October, November of 2022 there. And then at the bottom is the NOAA ENSO team predictions. All right, so this is the official forecast that you guys see every month. And basically, the take home is the NME predicted a big El Nino, and the NOAA ENSO team believed it. And that's really the big message out here, is that this is a neck and neck forecast. We were no worse than models, and we were no better than them, really. And this isn't always the case. There's definitely times, like say in 2017, when the enemy was predicting an El Nino, a reasonable, moderate, strong El Nino, and the team was not on board with that for specific reasons at that time. So anyway, this is good. I'm usually happy to see something like this. Now, people may be curious, well, what were you doing in 2015? The time there was another major El Nino predicted. Now, we started this process in, I think it was June of 2015, so I can't actually back it out to the period that I showed you in the previous slide. And in this particular case, in the observations here is in black, and the enemy predictions was, basically for a very, very substantial event that was much warmer than what happened in the observations. And the NOAA ENSO team, was pretty spot on here. I mean, the errors, if you look overall, were smaller for the NOAA ENSO team. And we were a little underconfident with that event. Maybe we should have been a little more confident. But yeah, it shows you that every event's a little different, and our interpretation of data can vary from event to event. So getting back to this one, there's obviously lots of ways to display this. This is showing every single forecast made for different forecast lead times. So this is the forecast horizon. This is the farthest out that we predict, and this is the nearest term. So you want your errors to be really small and close to zero in the near term. That means you're getting like the next season correct. And then generally errors get bigger as you get to larger lead times. And so in this particular instance in 2023, we were both making predictions that are colder than the observations. You could argue for some of these lead times, we are definitely, the NOAA ENSO team is slightly cooler than the enemy, but it's fairly hard to discern big differences here. Okay, so all right, we did pretty well, but some folks might be asking, wow, so that was pretty good, but why did you believe it? You said, there are times you don't believe it, especially in the spring when we're going through a period of time that we call the spring prediction barrier, which tends to be lower accuracy. And, we're very aware of the spring barrier, and we definitely do take it into account, but there are times where there are reasons to increase your chances of a potential event coming. You have to have clear reasons for it, obviously. But in at least April 2023, 2023, we said, let's do it. Let's issue the El Nino watch. And at that time, we had these large probabilities in excess of 80. We wrote there was a 4 in 10 chance of having a strong El Nino at that point, which is what we ended up happening. And the reason we believed it was we saw support from the subsurface ocean. Subsurface ocean was changing a lot and it was really warming up. So that was signal 1. Signal 2 was that we were seeing strong subseasonal tropical weather in the form of the Madden-Julian oscillation, just subseasonal variability. And basically that was forecasted to put down some very impressive westerly wind anomalies, which we did end up seeing. So that definitely got the event kicked off, and that was enough for a watch. But by June, those two things had come to fruition. We're seeing big changes near the surface. We were getting more confident in a stronger event. We had an excess of 90% probabilities in June. We had a 56% of a strong El Nino event, and that was written in our discussion. We were seeing the SOI really fall off here. We were seeing rainfall and convection enhance across the equatorial Pacific and drying near Indonesia. And so we thought that was enough, and sure enough, the event did grow from there. Okay, so that was from the perspective of the tropics. So now let's look at the impacts over the United States. And keep in mind, impacts are in the eye of the beholder. Not everyone just looks at temperature or precipitation like CPC tends to focus on. Some folks focus on global mean temperatures. Some folks are interested in shipping in the Panama Canal. There's all sorts of global impacts from ENSO. So, I'm mindful of the fact that this is a U.S.-based audience, and so let's focus on the season that the U.S.-based audience tends to focus on. And I should also mention there's tropical cyclone impacts across the world as well. A lot of focus on the August, September, October season in the Atlantic. But let's focus on the winter. And I know I presented some of this 1 year ago at the last West Watch webinar, where we talked about communicating ENSO and uncertainty. And basically, we all love these schematics because we get these questions about, well, what does generally what does El Nino look like? And so you explain that it's warming in tropical Pacific, it helps extend the jet stream southward and eastward, and the jet stream tends to lead to wetter conditions across southern tier of the United States. The pattern changes overall. You tend to get warmer temperatures in northern tier, and so on and so forth. So it's a really helpful thing for asking, answering that question, what does El Nino generally do? But as we try and, reinforce, and we do it yearly on the ENSO blog, there's a lot of variability from event to event. And these postage stamp maps are showing each winter in precipitation on the left and temperature on the right, and what happened during those El Nino winters. And it's really, I like these plots because they do show that no El Nino is exactly like another El Nino, but it's also kind of hard to pick up where the relationships are. Like, there's got to be some in between of this super simplified schematic and this, which is just flinging a lot of data at people. So I'm going to test drive a little bit a new way of displaying the uncertainty around El Nino, while emphasizing why we do tilt the odds in certain directions when we make a forecast. And so this comes from the CPC seasonal outlook team. I'm an ENSO forecaster. I actually have nothing to do with these maps. This is created by another team at CPC. And this was the outlook from October 2023. And clearly they were leaning hard on that El Nino signal. All right. So they had the wetter conditions across southern tier, drier north, warmer to the north, and then relatively cooler toward the south. Keep in mind these are probabilities. Like, we're not giving anyone a deterministic forecast here. The highest probabilities were actually for the Southeast and Florida, which have like a 60 to 70% chance. In the West, you can see the highest probability is somewhere around 40 to 50% chance of above average. And this is the way it always goes. And it is a challenge to communicate this, but it's also critical because we know El Nino never leads to the same impacts all the time. Okay, all right. Now that I've done my little lecture there, that's great. You guys understand there's uncertainty, but ultimately, tell me what happened in 2023-24. So I am showing you some fresh data. We're in mid-March, so I threw these together. This is December, January, February. Again, I'm emphasizing a seasonal timescale average. And on the left is what I call a reconstruction. And I don't think this audience necessarily wants all the detail, but a reconstruction is just taking the ENSO regression map and weighting it by the observed ONI value. So it gives you basically an image of what ENSO typically, or sorry, El Nino typically looks like, with wetter conditions here in the southern part of the region and then drier conditions to the north. Now, this is what happened this past winter for this 3-month period. And certainly you can see hints of El Nino here. We have wetter conditions across coastal California and to parts of the Southwest, and then these drier conditions in the northern Rockies, Idaho, western Montana, potentially a hit. But there's definitely a lot of deviations here too. Coastal Washington, Oregon, much wetter than expected. Some interesting pockets here of wet that weren't necessarily anticipated here. So I wanted to quantify this. Again, I was looking at that whole issue with the schematic versus the postage stamps, thinking there's got to be a better way to communicate this. So I said, let's create a match score. And for those who are more statistically inclined, this is just a pattern correlation. All right, but I don't want anyone to get too hung up on this. So larger scores mean a better resemblance to El Nino. So large positive scores means it looks like El Nino. And we can do this for every single winter. And so just so you're aware, this winter's match score or pattern correlation is 0.43. All right, so not bad, but not super high either. So let's look at this with respect to all December, January December, January, February winters. And how well did the precipitation anomalies relate to the expected pattern? Now, this is that 0.43 value that I just computed over here. So it's assessing how well this past winter matched with the El Nino composite or regression, basically. And so here we are. It was positive. It was very much consistent with an El Nino of this amplitude. And now why am I saying that? On the x-axis is the ONI values. And remember, we had a winter here that was almost about 2 degrees C. So there we go. And then so all our strong El Ninos are basically over here. Weaker El Ninos would be in this bucket. La Nina's over here. I'm not going to focus on that so much, but you can certainly invert the pattern in that and see how well it fits La Nina. But the bottom line is that larger values of this match score mean the winter precip pattern looks more like the typical El Nino pattern. But some things to notice. This is 97, 98. That's the big point of comparison for a lot of folks. Notice that it's not like all the dots cluster around 97, 98. There's no other dot that lies right on top of it or really that close to it. So this was a very exceptional event from the standpoint of precipitation. All right. And so here's some other strong events also came in with perhaps slightly more El Nino-like patterns. And this is, of course, our most recent event. This here is 2015-16. And so this was quite a departure Again, El Nino, especially stronger events, tend to stack the dice in favor of a more El Nino-like pattern, but there are exceptions to that. And some folks might say, whoa, what an outlier. There was nothing around it when it happened. And that's true, but if you evaluate the distance of all these dots from the best fit line, which is this black line, it's maybe within the range of what historically might have been expected. So you could actually imagine future events where you have dots in here as well. And that's just intrinsic. That just comes with El Nino. So here's to 2015-16, obviously really different from these other strong El Nino events. And here I'm just showing all of them side by side. And so depending on your interests, like say you're in, I don't know, California, you can see strong El Nino events almost very consistently give you wetter conditions over large parts of the state. I didn't in 2015-16, but that doesn't mean that there's no information there. You should probably still assess and assess your risk and consider these outlooks and the strength of ENSO in making basically these choices and judgments about whether to prepare for an El Nino. Maybe if you're in Pacific Northwest, you're a little bit more leery. There's definitely some examples of it being wetter, and not the dry signal that is always, in the composite. So this is just one way to show all of this. I focused on your region because this is the West Watch webinar. But at CPC, we do focus on the entire country, and we look at some other variables as well. So let's look at the entire country too. This is showing the same sort of diagram. Again, stronger El Ninos here, and you tend to have more positive and better match scores when you have a stronger event. And here is the total, CONUS whole precipitation anomalies. Here's the expected El Nino precipitation anomalies. And what you can see is it was a reasonable match score. In fact, maybe one that was anticipated if you use this best fit line, this black line. It seemed to score right up where you would be. And that is consistent with this kind of wetter than general average pattern that across the southern tier of the United States. It's slightly drier to the north, especially in northern Rockies, and maybe some parts of the Ohio, Tennessee valleys here. So yeah, all in all, pretty respectable score. This is 2015-16. It was also a poor match for the CONUS as a whole. This is showing temperature. All right, and temperature, at least this past year, was way up there. A really strong match score. But temperature, in contrast to precipitation, tends to have a lot more departures from the line. All right, so it's more common to see scatter, these really strong scores and really weak scores with respect to temperature. And I think that says something about the predictability of temperature versus CONUS precipitation, which is interesting if you consider that. But yeah, bottom line is we saw warmer temperatures across the northern tier. They were really warm. In fact, I would argue this is not just El Nino. There's some internal variability going on. There's trends and climate change. But all in all, the match of the pattern with cooler temperatures across south and warmer in north really did pan out here this past winter. And then lastly, this is showing 500 millibar heights. So it's just essentially pressure anomalies. This is showing what happened this past winter, and I put little higher and lower patterns here. This is a wave train, very classical one that tends to emanate from the Pacific during El Nino. And so this is the expected El Nino wave train. You see it aligns very well with the observed pattern. There's certainly exceptions. This low is not particularly pronounced. It's in the Eastern Pacific here, and you can imagine the jet stream extending out here through here, but it was not as evident in the Western Pacific. So there are some departures from what you expect for an El Nino of this magnitude. Okay, so that really wraps up what I wanted to talk about here. I want to encourage you to look for the ENSO blog post that's coming out, not this Thursday, but the following Thursday. It will be Thursday or Friday. I'm not sure exactly when they're going to publish it. But Nat Johnson, who is a collaborator of mine on the ENSO blog and is at NOAA GFDL, will look back at model predictions of precipitation. He did a really nice blog post in November of 2023 talking about the forecasted winter precip pattern in the United States. And so he's going to go back and verify those model predictions. And I really recommend you checking that out. Okay, so in summary, this event was well predicted. Not all are, but this one was, and I'll take it as a win. We gave 9 months of lead time from when an El Nino watch was issued to the start of this winter season. The strong El Nino was favored probabilistically from May 2024 onwards. And if you do rank the ONI, we were in the top 20% of all El Nino events. Even with a strong event, it's always important to emphasize that no El Nino impacts are not the same as another El Nino. And so it really is critical in your communication to talk about that tilt in the odds. And you'll get some practice because we have a La Nina watch right now. We issued one a month ago. So here we go. Practice talking about that uncertainty. In terms of El Nino related impacts, I would say this event performed pretty well, and as suspected for basically an event of this amplitude. For the western region specifically, in terms of precipitation, more of a mixed bag. Certainly there was some hits with the weather conditions across much of California and the Southwest, drier in northern Rockies, but of course the weather conditions in western Oregon and Washington were quite inconsistent. And that's kind of how El Nino goes. It tilts the odds, but doesn't guarantee them. So thank you so much. I really appreciate this opportunity to present here. And I guess I'll go ahead and see if anyone has any questions. Okay, here we go.
Thank you, Michelle. And yeah, I didn't realize how close we were to your last appearance, and maybe we're just going to make March, your standing
month.
spot, yeah, for Westwatch.
Poor people.
So we do have.
I'll try and bury things.
No, this was really wonderful. We appreciate it. We do have questions in the chat that are coming in, and I encourage folks to keep those coming. So the first one is you mentioned pretty conventional signal and dead on in terms of the outgoing long wave radiation anomaly. But it appears to be an unconventional signal with the convection more over the dateline and more to the west. If compared to 97, 98, and 82, 83, there is a huge difference. Are you saying this was a canonical Niño when you use those descriptors? Yes, this would be the pattern.
Right. So, that pattern correlation that I just did, I could do that for this domain here, right? And my guess is if I were to do that for this domain, the scaling would be for a pattern of this amplitude. 82, 83, 97, 98 were very exceptional events in the sense that the Eastern Pacific, particularly in this zone, so it wasn't staggered to the north of the equator, it was actually right on the equator, and it intensified as you got into the into the spring, and so that brought a lot of rainfall and flooding to Ecuador and Peru. Those are the only two events in our 1950 onwards record that had that particular effect, which is interesting to me because we haven't seen it since. I'm not sure if I would call that a conventional El Nino pattern at all. I would say this is much more of the pattern than that is. Those were pretty out there, but it's worth discussing and talking about it. I know that there were some efforts to actually design I think it was called the ENSO longitude index, which is this essentially finding the area of sea surface temperatures that would be more conducive to creating rainfall. And they argued after 2015-16 that the Eli value was small through here, and so that's why it did not rain in California. Well, guess what? This past event had a small Eli value as well, and it did rain in California, and it did in 2009 and 10 as well. So I think we should probably reassess what we consider conventional in terms of this particular domain and the wet conditions that we get in the Eastern Pacific, because it only really happened in those two events. Great question. Yeah, I can tell we've got ENSO nerds on this call because not everyone would know that.
Yeah, this is the most active of questions, and I'm really glad that we've left time to answer them.
I love it. I think it's great. Great question.
What about the effects on the coastal ocean along the West Coast? Sea level temperatures, alongshore currents, upwelling, things like that.
Fair. Yeah, so I'm at CPC, and historically we've clearly focused a lot on the CONUS temperature and precipitation, but as you point out, there are significant impacts on coastal ocean. In particular, El Nino tends to, we have some articles in the blog, but we don't focus on it as much from a forecast perspective. But El Niños basically tend to warm the ocean off California, Oregon, and Washington. And certainly I believe, saw that this past event. And so as a result, it tends to shut down some of the upwelling, and that region has a corresponding, impact on fisheries and all those biogeochemical things. So, I didn't do any in-depth analysis of that, but I guarantee you someone will be, and there will be some analysis on it. The other thing we have to remember is that we're seeing El Nino events in this much warmer world. So, we have this warmth on the equator, but we have a staggering amount of warmth in the oceans off the equator. So I think it's pretty clear we're not just seeing El Nino from the oceanic perspective. So some of that warmth may have had a climate change component, for example. But stay tuned. I'm sure all those assessments will be done.
Yeah, and to the question asker, our IU's partners will be back next month, and I assume this will be part of their conditions update. From the February call, I seem to recall that things were warmer, but not quite as coherent, I think, up and down the West Coast as they had been in years past. And I think the suspicion was just kind of more local scale variability was perhaps masking some of the El Nino force response along the coast. But if anybody from the IU's teams are on the call and want to correct me on that, please put your hands up, and you guys are the experts. To the next question, a paper reference. Lin et al. 2010 found the connection with the active MJO with more precipitation in Western Canada. Would you say the higher precipitation in the Pacific Northwest was connected to the more active MJO this season?
Yeah, it's a great question. I think this issue of climate timescales is a really hard one to communicate. So a lot of the analysis that I focused on was seasonal averages. And the reality is, when we're making predictions for a seasonal average, keep in mind season's like 90 days, right? So we're not going to know at the beginning of the season what the MJO state's going to be like, beyond, I would say, week 3, 4, all right, if I'm generous. So in other words, most of the season could have an MJO going on. We're not going to be able to predict it because it's a different time scale. That's just not the time scale that ENSO is operating on. So, and keep in mind too that the MJO can cancel itself out, right? Because it goes around the equator. There's going to be phases where it may lead to more precip in Western Canada, all right? But then it loops around, right? And it could actually go into phases that cancel that and may lead to less precip in Western Canada. So over the course of the season, you might see different loops of the MJO. And so that really complicates for me an assessment of the seasonal mean. All right. So yes, I agree that the MJO may have caused periods of increased rainfall over parts of the west coast, but I think it's a harder question to say whether that had its thumb on the seasonal mean button. I think those are slightly different questions, but great question.
I'm going to lump a couple questions about predictability together. Are either El Niños or La Niñas generally more accurately predicted? That's the first prediction question.
Yeah, this is a good question. I actually have a collaborator, the IRI, who has recently sat down with the IRI plume and did a little reassessment of using that data set, which is really nice. They do real-time forecasts monthly since 2002. So now they've got a really long record to look back on of real-time forecasts. And that's, to me, that's rubber hits the road. A lot of these hindcasts, while they're nice to have, they are not necessarily assessments of the type of skill you get when you're doing real-time prediction. Anyway, he basically argues in that La Niñas tend to be more forecastable, and I think part of that, and unfortunately, I'm not, I'm going to be a little unfair because it really depends exactly how you define the La Nina and so on and so forth. But the fact that La Ninas tend to reoccur for multiple years and back-to-back winters means that you can have a little bit of an edge in a La Nina happening and then it potentially happening again the following year. But there's some exceptions to that, and I'm not going to get into those details here, but I would say in general the La Nina's side tends to be, not always, a little bit easier to deal with. There are right now there's a huge forecast of opportunity in the sense that we're coming off a strong El Nino event, and that doesn't guarantee a follow-up La Nina, but more often than not, it does nudge things heavily that direction. And there are mechanisms in the equator and regarding the discharge of heat that really do kind of lean that direction. So it really depends. There are times where, again, El Nino has been predicted and the team was not confident enough to really come out with that forecast and provide those watches. So there's always these complicated ingredients on the ground that we're trying to understand and assess. Good question.
Another predictability question, and timely, I think. Subjectively, it seems ENSO forecaster and the spring predictive barrier have been performing better the past couple years. Any thoughts on if this is supported in the data? Possibly, are we improving model skill or just a chance outcome?
Yeah, so that's a really good question. Yeah, I think so. I mean, keep in mind we could bust hard coming up here. I don't think we will. We've got 80% probabilities for La Nina coming up. That's pretty high. But the 80 is still not 100, unfortunately. So let's not cheer too hard at this point. But yeah, I would say we're on a good run as of late. Why that is not totally clear to me, other than we're also going through some fairly high amplitude variations. This strong El Nino tends to be more predictable in the sense that it starts getting underway earlier in the year. The signals tend to manifest more clearly, and so we can sometimes, even in the spring, have some confidence that something is brewing. But it is hard to say that we've really gotten better at this, and whether that is tied to those higher amplitude variations of the last couple of years. And of course, we had that triple dip La Nina, and it was pretty clear to us it was having a hard time kicking out of that La Nina pattern. So that did offer some skill too. Good question. The spring barrier is still there. I want to emphasize that. There's still a lower accuracy time, and we may have surprises. We should always be a little on guard for that. But there are definitely some nice forecasts of opportunity that have been reoccurring here.
All right, we got a question from Dan McAvoy, who does the climate summary much better than I can. It looked like the 2015-2016 El Nino matched the 500 millibar pattern for a typical El Nino very well, but the precip in the West, not quite. Any idea on the causes, to really kind of nail the flow pattern or get close, and yet a difference in the precip?
I think that's a really interesting question. Keep in mind that the offshore flow is there, right? So this would be, the flow and the jet stream coming on here. So that is probably consistent with the precipitation that we saw in California. Maybe there was something in terms of the particular configuration of the height pattern here over the Gulf of Alaska, especially Alaska. I mean, look at that. It was really different for them. That was, helping create some local effects in this area that were wetter. This is also just 500 millibar. While that's great for overall steering currents across the globe, it's sometimes you do want to look more at the baroclinic zone and lower levels like surface to 850. So it's hard to say without looking a little more deeply at the data, but it's a very good question.
Yeah, and I'll add in my 2 cents. Some of those events in, let's say, Northern California, Pacific Northwest, huge dumps over short periods of time. It wasn't like the normal, you kind of have a flow of moisture kind of spread out drizzly over a couple of weeks. Some of these were really, really, brief, intense events. And I'm curious if that may be part of the story too, that really it wasn't their like seasonal drip, 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 but really these big events that make the DJF numbers look okay, but it really wasn't a very, very
right. Yeah,
rainy,
no, I think that's actually a really interesting question that I hope someone's looking at is, if climate change is increasing intensity of rainfall, does that make it more likely that you'll essentially see these seasonal patterns bend to the will of these smaller scale events? That's to me a really interesting question, and one I haven't seen satisfactorily answered anywhere.
Okay, our last one on the Q&A list. Can you comment on the depth of the warm water off the coast of North America in the coastal waters? It seems like it was not as deep as in some of the past El Nino events.
Are you talking about like on the equator or
off
like
of North America? Yeah.
Off of North America.
Yeah, so this may be another I use.
Yeah, I wouldn't know. Talk to your local, experts, I think, on that.
Okay, yeah, Andrew
not...
Leasing piped in and said, yeah, these were not so deep.
Okay.
But I think that's also consistent with what we saw from the IU's presentations in February, that it wasn't as kind of striking set of warm anomalies off the coast, either in their spatial extent or in their depth. But stay tuned, come back for next month, and I feel like we can.
Yeah, these are good questions to find an expert on and have them do a little deeper dive.
Well, great. Well, we've got a couple of minutes left, but we don't have any more questions. I just want to say again, thank you, Michelle, for being our sole presenter, doing a spectacular job, taking all these questions. But this is, in my mind, exactly what WestWatch is for, where we can do a little kind of assessment on the fly, learn a little science along the way, and kind of talk a little bit more holistically sometimes than we get a chance to do about these large scale climate things. I really also applaud the this pattern correlation
Hmm.
tool. I mean, I think this might be a really, really useful way to consolidate how we talk about some of these events. So I appreciate you sharing that with us and hope that we
Yeah, yeah,
continue to use
I
it.
would be interested in if anyone has feedback on this. I am typing up somewhat frantically. In fact, I think I should be able to hit submit by the end of the week, a paper on this, and I'm happy to send that to anyone. Just send me an email and I'll send you a pretty copy of it. But yeah, I kind of like it. I feel like it's not as overwhelming as this approach is, but of course it's not as simplistic as this is. So I am interested in people's feedback about this.
Thank you so much, Michelle. And yeah, you are very much at the end of your East Coast day. So thanks for
All
hanging with
right.
us, and take
Yeah.
care. And thanks everybody for listening and the great questions. And we'll hopefully see you again next month.
All right. Great. Thanks so much, everyone.